Consider differentiating 2x plus 3 squared. We can begin by letting y be equal to 2x plus 3 all squared, and then to get it in the right form to differentiate, we can expand the bracket. Here, if we expand, we'd get 4x squared plus 12x plus 9. This is now in the correct form to differentiate, so we can do dy dx, and this will give us 8x plus 12, and of course the constant disappears. So the answer is 8x plus 12. Now consider differentiating 2x plus 3 to the power 50. We can begin by letting y be equal to 2x plus 3 to the power 50, but expanding this will take a long time, even if we expanded using the binomial theorem. If we expand this, it has 51 terms. There simply must be a better way of doing it, and that brings us to the chain rule. So when faced with a problem like this, we're going to use the chain rule. Let's look at how it works. If we consider this function, let u be the bit inside the bracket, so u is going to be 2x plus 3. And if that's the case, y is equal to u to the power 50. We can now differentiate this. Du dx is just the differential of 2x plus 3, which is 2. And we can do a dy du, which is 50 times u to the power 49. We then form a chain. We're after dy dx, and this can be equal to dy du multiplied by du dx. These things are not fractions. However, if we look at them as if they are, we can see that the du's would cancel, leaving us with dy dx. So we have dy du, which is 50u to the 49, multiplied by du dx, which is 2. This gives us 100, 2 times 50, u to the 49, and of course u is 2x plus 3. So we have 100, open bracket, 2x plus 3 to the power 49. Let's go back and differentiate 2x plus 3 squared using the same technique. So we have y is 2x plus 3 squared, and instead of multiplying out the bracket, let's let u be equal to 2x plus 3. And if we do that, y will be equal to u squared. Du dx then is equal to 2, and dy du would be equal to 2u. Forming a chain now, we have that dy dx will be equal to dy du multiplied by du dx. Just check that if we treat these as fractions, we do cancel down to end up with dy dx, and you can see that we do. Dy du is 2u, multiplied by the 2, so we have 4u, and of course u is 2x plus 3. If we expanded this, we get 8x plus 12, which was our answer in the first part of the example.